Good day! The topic that I will discuss today is all about the mechanical rice thresher. So first, let me define what is a mechanical rice thresher. It states that it mechanically removes or separates the rice grains from the panicle or straw. It comes in a small capacity and large capacities. Compared to the manual threshing, it has a higher capacity and can actually save post-harvest losses. It is a custom built for performance efficiency. So basically, the mechanical rice thresher, it is a post-harvest machine na ginagamit ng mga farmer natin if the crop, specifically the palay, is being harvested manually. So ina-undergo siya sa rice threshing machine, which is its function is to separate the rice straw and the grain itself. And ngayon it is not commonly used, I guess, since we have a combine harvester and other developed machineries. The classification of mechanical rice thresher or the method of feeding, wherein we have two types of thresher. The first one is the hold-on thresher, which is it is the type of thresher wherein the panicles of the cut plants are fed into the threshing chamber while the stalks are mechanically or manually held during the threshing operation. So from the figure, you can see the hold-on thresher, which is it is primarily used in the areas wherein the rice straw is being bundled or collected for their future use or being stored. Since from the word itself, hold on, is it means you have the rice straw with the grains and hinahawakan mo siya and sinusubo mo lang siya doon sa threshing chamber, and then the threshing chamber will do its part na mag-separate ng rice grain. The second one is the throw-in thresher, which it is a type of thresher which detaches the grains by feeding the cattle plants into the machine. So in this type, hindi mo na siya hahawakan since yung buong rice straw with grains mo is papasok mo siya sa feeding board and then mapupunta siya sa feeding chamber as you can see in the figure. And then the blower will do also the crucial part here because ito yung makakatulong para mag-separate ng mga light materials and impurities. And as you observe, the rice straw will throw into the field and it will form like this, a mountain like of straws. And kung mapapansin nyo, commonly in the field, pag nakakita kayo ng ganyan, ibig sabihin, a throw-in thresher yung ginamit doon. Then for the operation, we have, so for the actual flow, it is a throw-in type of thresher which allows the cut plants to move in a helical manner around the threshing cylinder with the net effect of moving the material actually between the feeding discharge outlet. So when we say actual flow naman, it is like papasok mo doon, as you can see in the picture, papasok mo sa craft feeding cage and then there's an auger and the threshing cylinder which is consists the threshing chamber and then mag-i-spin siya. So here is the video of the actual flow for better understanding. The next one is the through flow thresher. It is a type of thresher wherein the cut plants are fed between the rotating cylinder and stationary concave, and the thresh material straws are discharged out of the threshing chamber tangentially. As you can see in the figure, the crop is being putted into the threshing chamber where the separation happens at the end of the cylinder, which is the crop material moved through the thresher drum in a perpendicular direction. The crop material is fed into the thresher drum at one end and exits at the other, while in actual flow, go back, the thresher works by moving the crop material in a parallel or axial direction relative to the thresher drum. The crop material flows along the length of the drum. So let's proceed now to the different types of threshing cylinder. The first one is the peg-tooth cylinder. It is a type of threshing cylinder wherein spikes or pegs are attached on the periphery of the cylinder in tandem or in helical arrangement. The second one is the rasbar cylinder. It is a type of threshing cylinder wherein threshing is done between bar-like protrusion in parallel orientation laid on the periphery of the cylinder and stationary bars built into or attached to the concave grate. So this is the picture of the rasbar cylinder. It is equipped with rows of rasbar. It is essentially metal or rubber bars with teeth or projection that rotate on the cylinder. The third one is the wire loop cylinder. This is a type of threshing cylinder wherein wires of the same arc and size are attached on the periphery of the cylinder in tandem arrangement with or without the threshing concave. So this is the figure of the wire loop cylinder wherein it is commonly used on the hold-on type thresher. For the parts and its function, for the functional components of threshing unit, there are five, which consists of the feeding unit, cleaning unit, power transmission, mainframe, and the transport unit. The first one is the feeding unit, which is responsible for having an efficient and continuous feeding of the rice plants into the threshing mechanism. It consists of one part, which is the feeding board. It is the top part of the feeding unit where the harvested rice plants are initially loaded. It provides a reservoir for the rice stalks and allow for the controlled feeding into the threshing mechanism. So basically, the feeding unit is ito yung nagre-receive ng mga rice stalks para pumunta doon sa threshing chamber. Next is the threshing unit. It is responsible for separating the rice grains from the stalks and husks, which is the threshing cylinder that has two chaff cutter blades and beaters. Chaff cutter blades cuts two crops into the pieces and beater helps to detach grain from the crops. The concave, it separates the grain from the crop and removes grain from the straw. Concave is provided in the thresher to hold the fed crop inside the threshing chamber and allows only grain and small amount of chaff to pass through it. So, the threshing cylinder is also known as a threshing drum or rotor, a cylindrical component equipped with various types of threshing element, which is yun nga yung sinabi ko kanina, the peg tooth, the rasbar, and the wire loop cylinder. Then, the concave naman is, it is a curved or contoured surface na nakaposition below dun sa threshing cylinder. So, it is effectively trap and support the stalks while allowing the separated grain to fall through. And it also helps in further separating the grain from the straw. Next is the cleaning unit. The cleaning unit is responsible for further separating impurities such as straw, chaff, and dust from the rice grains that have already been threshed. From the cleaning unit, there are four parts. Under, which is the blower. An air blower creates an airflow within the cleaning unit. This airflow helps to separate lightweight chaff and dust from the rice grains. The chaff and dust are blown away while the clean grains fall through the screens. Cleaning sieves or screens are sets of vibrating or oscillating screens with various sizes of perforation or mesh. The grain outlet. The grain outlet is where the separated rice grains are collected and discharged from the threshing unit. The outlet. Straw outlet is where the separated straw and husks are expelled from the threshing unit. Next is the transport unit. It is responsible to move the machine into one place to another. There are one part under this, and this is the transport wheels. Thresher is provided with wheels at its legs so that transportation can be done easily. These wheels are made mostly with cast iron, but new and large capacity threshers are equipped with pneumatic wheels for better performance during transportations. Next is the main frame. This is a very strong frame which provided in the thresher on which all the functional parts are attached. The frame is made usually of heavy angle iron sections. It should be strong enough to sustain variation of machine during operation in the field. So for the main frame, di ba yung mechanical rice thresher is merong shaking mechanism which is shaken with a crank attached to the screen. Therefore, the main frame is built to withstand the stresses and vibration associated with the threshing operation. It is also contribute to the overall safety of the thresher. So now let's proceed on how to operate the mechanical rice thresher for axial flow thresher according to the ERI. So before operating the machine, for the positioning of the thresher, the first one you should do is to position the thresher on a level area close to the crop stock to minimize handling and shattering loss. Second is the spread cloth canvas or mat underneath the thresher to collect the spilled grain from the grain discharge shoot or due to the shattering during the handling. Third is install the cylinder cover and feed tray if dismantled during field transport. The fourth is position the thresher so that the straw is thrown with the direction of the wind. This will eliminate the blowing of straw, chaff, and dust back towards the operator and the threshed grain. To check the machine, the fifth step you must do is to check each belt's alignment and tension. Adjust the idle pulley on the blower or cylinder to correct tension. Improper alignment and tension are major causes of premature belt failure. Sixth step is to check the pulley surfaces. Raw grooves must be smoothened into a fine tile if needed. Cracked pulleys should be replaced immediately. Seventh step is to open the cover and check all pegs on the threshing cylinder for tightness. Loose pegs will damage the machine and can be dangerous to the operators. The eighth step is to examine the peg teeth for wear. Maximum wear occurs at the feed end of the cylinder and is more prominent at leading side, the direction of rotation. To check the machine, the ninth step is to rotate the threshing cylinder manually at least 5 revolutions to ensure that there are no obstruction or interference. 10th step is to make sure that there are no loose or missing bolts and set screws. Tighten or replace as necessary. 11 is to lubricate all bearings with good quality grease. See maintenance and service section. The belt idler or oscillating screen eccentric bearings are lubricated for life, thus require no lubrication. 12th step is to check the engine oil and fuel levels. Follow the engine's manufacturer's recommendation. The 13th step is to start the engine and allow it to warm. Feed the thresher with crop to be threshed for performance checking. By operating the machine, the first step you must do is to start the engine. Second is to load the feed tray with harvested crop with the panicle away from the operator so it is fed panicle into the thresher. The third is to feed the crop at a uniform rate. Adjust the feed rate to match the condition of the material. Maintain maximum feeding rate without overloading the engine. Fourth is to adjust the blower openings to ensure sufficient airflow needed for winnowing. Open slowly to provide more air for the cleaner until a small amount of mature grains flow over the windboard. Fifth is to adjust the angle of the windboard. For dry peanut, windboard should be set as its maximum inclination. For threshing wet peanut, the inclination of the windboard must be reduced. To obtain extra clean paddy, set the windboard at a low inclination and increase the air shatter opening. This process will blow more grain over the windboard, but this can be recovered by recycling and separated impurities through the thresher. The sixth step is to always use a stick to remove clinging straw from the oscillating screen to protect hands from possible injury. Knowing on how to operate a thresher is a crucial because thresher are heavy machinery with many moving parts which can be dangerous if not operated correctly. Understanding on how to use a thresher safely helps prevent accidents and injuries. Moreover, proper orientation ensures that the thresher functions as its best, resulting in a higher efficiency and productivity during harvest. This is important for both small-scale and large-scale farming. And I think this is the end of my discussion. Thank you.